Okay, as we look at problem number 1, it says write the first 5 terms of the sequence whose general term is given. And we've got a sub n equals 4 times 3 n to the minus 1. So remember that the first 5 terms is just going to be a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. This is just a matter of substitution. So using substitution, I'm going to take this 1, I'm going to put it into my equation in place of n. So now I got 3 times 1 is 3, 3 minus 1 is going to be 2, and then this 4 times 2 is going to equal my a sub 1, which is 8. A sub 2, we're going to substitute in 2 in place of n, so 3 times 2 is 6, 6 minus 1 is 5, and then take this 4 right here, times that by the 5, and you'll get your answer of 20. A sub 3, again substitution, substituting this 3 in place of n, so we got 3 times 3 is 9. 9 minus 1 is going to be 8, and then multiply this by 4, and you'll get 32. And then on this last one, again, just using substitution. So substituting in a sub 4 into your equation. So 4 goes in place of n. So 3 times 4 is 12. 12 minus 1 is going to be 11. And then multiply that 11 times 4, and you get 44. And a sub 5, substituting that 5 into your equation. Get 3 times 5 is 15. Subtract that 1, which is going to be 14. 4 times 14 gives you a total of 56. So there's your sequence of the first 5 terms. So on the first term, you've got 8, a sub 1 equals 8, a sub 2 equals 20, a sub 3 equals 32, a sub 4 equals 44, and a sub 5 equals 56. Okay, on number 2, the directions on number 2 says write the first 4 terms of the sequence defined by the recursion formula. So it says that a sub 1 is going to equal 5. So this is given to us. A sub 1 equals 5. And then a sub n equals 2 times a sub n minus 1. And you're going to notice that this is a recursive formula. Remember, recursive formula is a description. It's not an actual equation, although you can treat it as an actual equation. But this right here is our subscript. So that's not actually part of the equation. So basically what this is telling me is this is telling me to find the next term, a sub n, take the previous term, which is a sub n minus 1, and multiply by 2. So it's more of a description rather than an actual equation. So this right here means the previous term. So don't forget that a recursive formula is not an actual equation. So basically I just have to take my first term, which will be given to you, and I'm going to take this first term, which is 5, and then this next term is just going to be 5 times 2, which is 10. Now that I know that that term is 10, so this says take the previous term, which is 10, multiply that by 2, and you'll get 20 for your next term. Now following the formula, this says take the previous term, which is 20, so to find a sub 4, take 20 times 2, and you'll get that answer of 40. On number 3, working with our factorials, it says we've got 7 factorial times 5 factorial, 2 factorial. So remember, factorials mean just repeated multiplication, and the next term that you're multiplying by descends by 1. So 7 factorial is the same thing as 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what 7 factorial means. So when I actually do this problem, 7 factorial over 5 factorial, 2 factorial, I can actually, when I go starting my multiplication sequence, going downward, I got 7 times 6, and notice I stopped here at 5 factorial. Now the reason why I stop at 5 factorial is because there's also 5 factorial in the denominator. So remember, as you're doing these problems, you start to write the factorial of the largest factorial, and then you stop because you're going to be able to cross it out. So I got 7 times 6. Now 2 factorial means 2 times 1. So again, doing my cross canceling, so 6 and 2. So that's going to become 3. And 7 times 3 divided by 1 is 21. On number 4, It says I have the summation of I equals 3 to 6 of the equation 4I minus 3. So this problem is actually meant out to be done the long way. It's not meant to be used a formula. Because this right here, so my I equals 3 is my start of my sequence. And this is the end of my sequence. And so to list out my sequence, I start at I sub 3, I sub 4, I sub 5, and I sub 6. So with each one of these equations, so here's I sub 3. I'm going to take 3 and put it in my equation. So I get 4 times 3, and then subtract 3. So 4 times 3 is 12, and 12 minus 3 is going to be 9. I do that with all my other equations. So here's 4. I'm going to substitute 4 in my equation, I. So I get 4 times 4 is 16. 16 minus 3 is going to be 13. I sub 5. Take this 5, put it in my equation, I. So I get 4 times 5, which is 20. And 20 minus 3 is going to be 17. And now my last term, I've got I sub 6. So substituting 6 into my equation, I got 4 times 6 is 24. And 24 minus 3 is going to be 21. So now that I've found all of my answers to I sub 3, I sub 4, I sub 5, and I sub 6, this last thing I need to remember is this little summation symbol means add them all together. So all I have to do is just take my problems and just add them together. So I'm going to take my answers. So here's 9 plus 3 plus 17 plus 21. So 9 and 3 is going to be 22. 22 and 17 is going to be 39. And then 39 and 21 is going to be a total of 60. So your answer to this summation, the summation of I equals 3 to 6 of 4I minus 3, the answer is D, which is 60. On number 5, it says it wants me to find A sub 13. And I notice that my equation starts off with 15, my sequence starts with 15, 18, 21. So you're going to notice these are going up by 3. Now that is known as your common difference. So we're going to use the arithmetic nth term formula, and you're going to notice that this formula, it will be given to you on your formula sheet that will be attached to your test. So basically, you just have to remember what each piece of this formula means. So this A sub 1 is your first term, and n minus 1 is the number of terms that you're going to. And then this D is your common difference. Well, your common difference is right here, which is at 3. So rather than writing out this sequence, 15, 18, 21, 24, 27, 30, and so on, to find the 13th term, I just have to remember that my sequence says that, first off, here's my first term, which is 15. And then here is my number of terms that I want to find, so that is 13. And the number of differences that it's going to take to get to that 13th term, so that's subtract 1, so there's going to be 12 differences. And remember my differences were 3, so substituting in, that's going to be 3. So now working this out, 13 minus 1 is going to be 12. And 12 times 3 is going to be 36. And then add that 15 to my 36, and I get my answer of 51. So let me scroll this up just a little bit. So substituting that in, you got 15 plus 13 minus 1 times 3. So your answer is 51. Okay, on number 6, it says find the sum of the first 20 terms of the arithmetic sequence. You got 19, you have 25, you've got 31, you've got 37. So notice that this sequence right here, it's an arithmetic sequence, which means there's a common difference. So this sequence is going up by 6s. So to be able to find this arithmetic sequence sum, I have to use my formula discovered by Carl Friedrich Gauss when he was in the 3rd grade. Remember, he added the first term plus the last term, and then he found half the number of terms. Well, the problem with this equation that I have right here, this sequence, I don't have my 20th term. It's somewhere over here. So the very first thing I need to do is I need to go ahead and find my 20th term. So to find my 20th term, I'm going to use that formula that I used previously. So it says to find the last term, use the arithmetic nth term formula. So here's my formula. A sub n equals a sub 1 plus n minus 1 all times d. So we're going to scroll back up here. And you're going to notice the first term of my sequence is 19. So I'm going to go ahead and substitute in 19. And you're going to notice also that I want to find 20 terms. So I'm going to substitute those numbers into my equation to find that 20th term. So once again, here's my first term, 19. I want to find 20 terms, so I'm substituting 20. And you remember a common difference is 6. So take my calculator or take your math and just take 20 minus 1, get 19. Multiply that times 6 and then add 19 to that. And you'll get a total of 133. Okay, now that I have that 20th term, which is 133, I can just remember here's my formula for the nth term. So this 19 is my first term. This 133 was my 20th term. And remember this formula said we take n all over 2. So if I pair them up, that's 20 terms divided by 2. So put that in your calculator, take 19 plus 133, times that by 10, and you'll get your answer of 1,520. So that answer is going to be B. Okay, on problem number 7, it says find a sub 11 when a sub 1 equals 5, and your common ratio is going to be r equals 3. So on this problem right here, using your geometric nth term formula, so using your geometric nth term formula, you can go ahead and substitute this in. So this formula will be given to you on your formula sheet on your test. So notice that you're just going to go ahead and substitute in a sub 1 and then your common ratio, which is r, and then take that to the n minus 1. So here's my a sub 1 equation, which is 5, substituting that in. It says my ratio is 3, substituting that in. And I want to find the 11th term, so I'm substituting 11, and that becomes 11 minus 1. Go ahead and put that into your calculator. So 11 minus 1 is going to be 10. So type in your calculator, 5, and you got times 3 to the 10th. So putting that into our calculator, so take 5 and times, type in 3, hit your power key, all to the 10th power, hit enter, and it looks like it comes out to be 295,245. So here's my answer, which does look like it's going to match up with the answer of C. On the next problem, on problem number 8, the directions on problem number 8 says find the sum of the first 9 terms of the geometric sequence. We've got 4, we've got 12, we've got 36, we've got 108, we've got 324. So to find the sum of our first 9 terms, we're going to use the geometric sum formula. And so notice with your geometric sum formula, that formula will be given to you on your formula sheet on your test. Here's your first term, a sub 1. And here is our number of terms, which is n. R is our ratio, and that is the amount that it is being multiplied by to get to the next term. So we just have to find those. So notice here's a sub 1, which is 4. And R, we're going to find that here. So R, we have to find. So R looks like it's going to be, to find R, we went from 4 to 12 to 36 to 108. So you can see that's definitely going up by a ratio of 3. Or if you need to find that ratio, you can always take your a sub 2 divided by a sub 1. And so that's going to be 12 divided by 4. And then that gives you the ratio of 3. So our ratio would be 3. And then, of course, our n, our number of terms, is going to be 9. Substituting in those numbers. So here's our formula. And we're going to substitute those numbers into our formula right here. So notice our first term was 4. Here's our ratio, which is 3. So Substitute those in right there. And then the number of terms that we want to find is equal to 9. Now taking your calculator, we're going to go ahead and type that into our calculator. So if you can put this into your calculator, make sure you put parentheses around the numerator. So you got a parenthesis, and then you're going to type in 4. Then you're going to put in another parenthesis, and we got 1, got minus, and then we're going to take 3, hit your power key all to the 9th, and then arrow on over, hit a parenthesis, and then a parenthesis. So I've got parentheses around my numerator, and then divide, and I'm going to put parentheses around my denominator. So I got 1 minus 3 in parentheses. Then hit enter, and your answer comes out to be 39,364. And that looks like that's going to match up with the answer of D. Okay, looking at this next problem on number 9. Number 9 says it wants us to find the sum of the infinite geometric sequence. And it starts off with 2, and then goes to plus 2/5, plus 2/25, plus so on and so forth. So this formula is going to be given to you on your formula sheet. So this formula for an infinite geometric sum, you're going to notice that you want to find your first term, and it's going to be 1 minus your ratio. So to go ahead and find your first term, it's given to you right here. So here's the first term, which is 2. So to find this ratio that it's going up by, you just take, again, r is going to equal a sub 2 all over a sub 1. So a sub 2 is going to be 2/5. And that's going to be divided by 2. So you flip and you multiply. So this is going to be 2/5 times, so remember this is 2 over 1, so that's times 1/2. The 2's cross out, and you're going to be left with a ratio of 1/5. So here's my ratio of 1/5. So substituting in my ratio of 1/5, and I'll go ahead and take your calculator and just go ahead and put this into your calculator. So in your calculator, typing in this problem right here into your calculator. Yeah, we'll go over here on me, so let's go ahead and clear that out. So you're just going to take 2, divide by, and you're going to put parentheses around 1, minus, and then we got 1/5. And since our problem was given to us as a fraction, we're going to change it to a fraction. So then just hit your math key, and then hit number 1 for fraction, and it'll give you to your answer as a fraction. So here is our answer of 5/2. On number 10, so let's scroll down here to number 10. So let's go ahead and use the binomial expansion on number 10. It says we got 4x plus 3 all to the third. So we're going to take this to the third power. So first off, we're going to use Pascal's triangle to find our coefficients. So remember, Pascal's triangle starts at a 1, and then the 1 stay on the outside, and then you add the number above it. So this 1 plus 1 is going to give you 2. The 1 stay on the outside, and then this 2 plus 1 gives you the 3, and 2 plus 1 gives you this 3 right here. Now again, on your binomial Pascal's triangle, see the 1 stay on the outside, and then I add these numbers above it to give me my 4. So 3 plus 3 is going to be 6, and then 3 plus 1 is going to be 4, so on and so forth. So that's the pattern. We'll scroll up and just do one more on our pattern. So again, the 1 stay on the outside, and then the number above it. So it looks like this kind of got cut off on the copier. You got a 1 right here, and then 1 and 4 is going to be 5, 6 and 4 is going to be 10, 10, 5, and 1. And so just as a reminder, that very first 1 that you wrote down, that's going to be to the 0th power. And then it goes to the first power, second power, third power, fourth power, and fifth power. Well, if I look back at my equation says that it's to the third power. So that means I'm going to use my third power coefficients. So that's the first thing you want to do. You're going to use Pascal's triangle to find your coefficients. And then just remember your first term descends. So here's my first term, 4x. And then my last term ascends. So my last term, which is 3, is going to go up. So now putting this in expansion, so you're going to notice my equation was 4x plus 3 all to the third power. So here's my coefficients from Pascal's triangle, 1, 3, 3, and 1. And now my first term, which is 4x, is going to start at the leading power and it's going to descend. So 4x to the third, 4x to the second, 4x to the first, and 4x to 0. Now my last term, which is positive 3, that's going to start at 0, and it's going to go up to 3. So 3 to the 0, 3 to the first, 3 to the second, and 3 to the third. Okay, now that I've done that, I just need to go ahead and simplify it. So to simplify this, I'm going to take my 4, take it to the third power, and then multiply that by 3 times 0. 3 times 0 is 1. 4 to the third power is 64. So 64 times 1 is going to give me that 64. And then I still have my x to the third. So that first term is going to be 64, x to the third. Now I've got 4 to the second, which is 16. And I've got 3 and another 3 here. So that's 3 times 16 times 16. Or sorry, 3 times 16 times 3. And 3 times 16 times 3 comes out to be 144. And then notice I still have my x all to the second power. Now on my next term, here I've got 4 to the first, which is 4. I've got 3 to the second, which is 9. And I still have my 3. I've got 3 times 4 is 12. And 12 times 9 is going to be this 108. And then notice I still have my x to the first. And then on my last term, this is 4x to the 0, which is 1, 3 to the third, which is 27, and 1 times 27 is going to be 27. So if I was to multiply this out, I'd end up with an answer of 64x cubed plus 144x squared plus 108x plus 27. Okay, and number 11. Says a restaurant offers a choice of 4 salads, 10 main courses, and 4 desserts. How many possible 3-course meals are there? Well, according to the fundamental accounting principle, to find all your choices, all you have to do is just multiply them all together. So since I've got 4 salads and 10 main courses and 4 desserts, I just multiply those together. So I take 4 times 10 times 4, and that gives me a total of 160. Okay, number 12, it says, in how many ways can Susan arrange 10 books into 3 slots on her bookshelf? So notice that once you've used a book, that book has been used, so that means that order is important. So since order is important, that is a permutation. So that means she's got 10 books. She's going to pick 3 of them to put in the slots. So you're just going to take your calculator. So when you take your calculator for this problem right here, we'll slide our calculator over here, out of the way. Well, maybe we will. Let's see. Okay, now you just take your calculator. And once you've got your calculator on, go ahead and type in 10. Then hit your math key, and then arrow on over to PRB, which stands for probability. You're going to notice number 2 is your NPR key, so hit 2 for NPR, and then you're going to type in 3, and then hit enter, and the answer comes out to be 720. On this next one, on number 13, just remind you again, with permutation, order is important, or in other words, there can be no repetition. And then it also talks about combination. So combination, just remember that on a combination, order is not important. In other words, repetitions are allowed. So as you read your problem, you got to decide which one it matches. And so it says a church has 7 bells in its bell tower. Before each church service, 5 bells are rung in sequence. No bell is rung more than once. How many sequences are there? So notice by the definition of a permutation, that's the one that it matches, because order is important and there are no repetitions. So if you read your problem, it says no bell is rung more than once. So since no bell is rung more than once, that means that I don't have any repetitions in there. So that's why on number 13, that's why it comes out to be permutation. So that answer is going to be A. On number 14, it says a stack of 7 different cards are shuffled and spread out face down. If 5 cards are turned face up, how many different 5-card combinations are possible? So that definitely matches the definition of combinations. In fact, it even calls it combinations. So that means that I've got 7. And it says different cards are shuffled. And then spread out in front of that is 5. So that's going to be a 7C5 combination. So since that's a 7C5 combination, you're just going to take your calculator and type in 7. And then go to your math. Go to your probability. And that one is number 3, our NCR key. Type in 5. Hit enter, and that answer comes out to be total of 21. Okay, on number 15, it says, use the empirical probability formula to solve the exercise. Express the answer fraction and express the probability as a decimal. It says round to the nearest tenth necessary. So on number 15 it says the table below represents a random sample of the number of deaths per 100 cases for certain illnesses over time. A person infected with this illness is randomly selected from all infected people. Find the probability that the person lives 3 to 4 years after diagnosis. So if you look at this problem, you go to 3 and 4, and it says the number of deaths is going to be a total of 35. So just looking at the chart, this 35, this comes right off that chart. And then it's a total of 100 cases, so that's going to be 35 over 100. And then 35 divided by 100 is going to be 0.35. On number 16, it says use the theoretical probability formula to solve the problem. Express the probability as a fraction, reduce to lowest terms. It says use the spinner below to answer the questions. Assume that it is equally probable that the pointer will land on any one of the 5 numbered spaces. If the pointer lands on a borderline, spin again. So notice, as you look at your spinner, it has numbers 1, 2, 3, 4, and 5. It says find the probability the arrow will land on a 2 or a 5. So the probability if it lands on a 2 or 5, so remember that's the probability of 2 plus the probability of 5. So the probability of 2, there's only one space that's 2 out of 5. And also, probability of 5 is 1/5. So now add those together. 1 plus 1 is 2. Keep the same denominator, which is 5. So the probability is going to be 2/5. On number 17, it says the table shows the probability of a certain disease for men by age. Use the information to solve the problem. Express all probabilities as decimals. Estimated to 2 decimal places. So you're going to notice on the one side of the tab, you got age 20 to 24, 25 to 34, 35 to 44, 45 to 54, so on. And so the probability of 20 to 24 is less than 0.008. 25 to 34 is 0.009, 35 to 44, 0.14, so 45 to 54, 0.39, so on and so forth. So it says, what is the probability that a randomly selected man between the ages of 55 and 64 does not have this disease? So all you have to do is just look at your chart. So the probability that he has the disease is going to be 0.42. So there's a 42% chance that he has the disease. So the probability that he does not have the disease, you're going to have to subtract that from 1. So probability he does not have the disease is 1 minus the probability that he has the disease. So that's 1 minus 0.42. So 1 minus 0.42 comes out to be 0.58. So that answer is going to be C. On number 18, it says the table below shows the probability of dying from 4 conditions in the U.S. expressed on probabilities decimal to 3 decimal places, assuming you cannot have more than one disease at a time. So you look at disease A, it's got a 33.3% chance. Disease B, 23.0%. Disease C, 5.8%. Disease D, 4.7%. It says, what is the probability of dying from disease A or B? So remember, A or B, that would be the probability of A plus the probability of B. So we just got to find the probability of disease A. The probability of disease A is 30.3%. The probability of disease B looks like it's going to be 23%. So now add those together. We've got 0.303, 0.230. Add those together, and you get a total of 0.533, which answer is A.